Hello class, today we're going to talk about recursion and the n-queens problem. Recursion is a very powerful tool in computer science because it allows us to solve very large problems by reusing just a few lines of code. One of the main parts of a recursive function, where it gets its name, is the fact that it calls itself within the body of the function. This makes recursion a very dangerous tool as well because we can easily create infinite loops unless we have a sufficient base case within our function. So one problem that recursion can be used to solve is the n-queens problem, or how do we fit n queens onto an n by n chessboard in such a way that none of them are attacking each other. We can use recursion for this, or we could have used a brute force method, but just looking at the permutations of queens that we can fit on this chessboard, we can go 1, 2, 3, 4. Well, that doesn't work. So let's go 1, 2, 3, 4. Also doesn't work. And so on. We could go through thousands of different combinations before we hit one that works. Using recursion, we could create a method that checks where the first queen can be placed, checks the second, third, and fourth, and whenever we run into a problem, we recursively backtrack and replace the next queen onto the board. So, for example, let's create a very simple function called place queen. And what this function will do is place queen on the first available space it sees. In this function, we're going to have to check whether the space is available, then place the queen there, if available, and then lastly call our function again. So if we run through this program right now, let's check our first space. Okay, obviously available. Place it there. And then place the queen, call the function again. Let's place our second queen. Well, it can't go here, that's already taken. It can't go here, that's being attacked by the queen. Or here, or here. It can't go there, the queen's attacking this way as well. And it can't go here because the queen's attacking the diagonal. But then we get a space our queen can go. So let's place it right there. Okay? We've placed our queen. Let's try it again. Recall. Taken, all these are taken. This is taken by that queen, this is taken by that queen, and that queen, and that queen. Oh no, we run into a problem. There's nowhere our function, our third queen can go. So, we need to backtrack. But this function doesn't have any way to backtrack yet. So first we'll need to put in a base case. We need to terminate this program when we hit our fourth queen. And then we'll need to make use of the stack. When we call our function the first time, function place queen, PQ, within its body it checks to place the queen, then it calls place queen again. Okay, here's number 2. And so on, so on. We get our 4 calls on here. But before our function calls itself, it first places a queen. So at this point we have 1 queen on the board. Here we have 2. Here we have 3. Here we have 4. And this one doesn't call again because our base case has occurred. We have n queens on the board, in this case 4. So we do not call it again, and our program will resolve top down. First queen gets placed, second queen gets placed, third queen gets placed, and if it can't be placed, we're back on top of the stack, and we'll run through it again. So using recursion, we can easily keep our calls on the stack until they're done, and solve the problem using recursion.